Hello students, and welcome to the continuing lesson on exponential growth and decay. And in this video we're concerned with these three problems, 3, 4, and 5. Write an exponential function to model the following scenarios. The initial amount is 25, the growth rate is 2.38%. Okay, so one thing we need to know is that 2.38% as a decimal, that's a terrible percent sign, 2.38% is really equal to 0.0238, okay? And this is the rate, this is R of growth. Remember, this is, we're told that this is a growth rate. Okay? So that means f of x is equal to the initial amount. I'm going to keep this here to keep referencing it. The initial amount here is 25 times the base, okay, to the x. But remember from the previous video that the rate is equal to the base minus 1, so that means r plus 1 is equal to the base. So in this case, r is 0.0238 plus 1 is equal to the base. So our function then is f of x equals 25 times 1.0238 to the x. Okay, and you can see this is a growth function because the base is bigger than 1. And if you subtract 1 from here, you would in fact return to this growth rate. Now let's look at number 2. The initial amount is 3,500 and the decay rate is 0.047%. I said number 2, I really meant to say number 4. Okay. So again, the decay here is 0.47%, which is really equal to 0.0047. And this is R here. This is the rate of decay. Okay? And remember that 1 minus the base is equal to the rate of growth. So therefore 1 minus R is equal to the base. Okay, so that means 1 minus 0.0047 is equal to the base, and this is 0.9953. So this is our base. Okay. Our initial amount is 3,500. So our function, I'm just going to call this g of x, is equal to 3,500 times our base, 0.9953 to the x. And you can check that this in fact works in one of two ways. Looking at this base, it should be less than 1. If you take 1, subtract this number, you should return back to the rate of decay. And now looking at our last example, it says the initial amount is 18.7 and it doubles every hour. So the fact here, that's number 6, doubles. This means that there's a base of 2. So it's going to be f of x equals something times 2 to the x. Base of 2, okay? Because for it to double, it's just got to increase. It's got to double every time, being multiplied by 2. We already know that the initial amount that they give us was 18.7. Right, this is a given number in the problem here. I'm not calculating this or anything. It's just given in the problem, and so 18.7 times 2 to the x. And if we want to find the rate, and it doesn't tell us the rate here, but the rate, remember, r is equal to 1 minus b. I'm sorry, b minus 1. Well, this is base is 2 minus 1 is 1. So the rate of growth here is 1. And this is really saying it's growing by 100%. Doubles mean that it grows by 100%. Okay? And hence this is really saying 18.7 times 1 plus 1 to the x. Okay, same thing, same idea. I just wanted you to see where these numbers come from, so it doesn't seem totally weird and random. So hopefully you get some good practice here at writing exponential growth and exponential decay functions. In this next video, we are going to discuss examples of a word problem that involves growth and decay.